Hi, I'm Rich with insideHPC. We're here at SC17 in Denver, Colorado, and we're here at the HPE booth with Bill Mannel. Bill, welcome to Denver. Thanks. What are you showing here? This looks very unusual. It looks like an engine.
Oh, well, it actually is. It's a hydrogen fuel cell. And we actually partnered with Daimler, who's the parent company of Mercedes-Benz, and NREL, the National Renewable Energy Laboratory, to do a project around using hydrogen fuel cells to actually power supercomputers. So in this case, this is Daimler's hydrogen fuel cell that they would use in a car or a truck. It's under development. And so we actually have a demo where we've actually powered our Apollo 6000 Gen 10 system at NREL using this technology.
How much kilowatts can this produce?
So this can actually support up to 50 kilowatts. So it can support a fair amount of compute from that standpoint. It's great for applications that might be in the field, let's say for disaster recovery with FEMA, maybe for military uses, maybe for areas where there's not clean power, like in a lot of places in the world from that perspective. It can also be used for redundant power in a data center where instead of having redundant power supplies across a whole bunch of servers, you could just use this as your additional power supply.
Science fiction, great stuff.
Yeah, exactly.
All right, well, what else you got here in the booth this week?
Well, let's walk around here. We'll show some of our new the machine technologies.
Okay, Bill, what are we looking at here?
This is actually part of the machine technology. So we've been talking about this for a while. We demonstrated the machine, if you will, that supported up to 160 terabytes of shared memory. So this is some of the technology that we've been working on in Hewlett-Packard Labs, allowing customers to basically create what we call MemDriven Community, or MDC. So now the memory becomes the center, and then we basically attach processing elements, whether they're normal microprocessors or accelerators. You can have I/O and so forth, basically around this central pool of memory. But it's available, it's high speed, so it can solve a lot of different problems from that standpoint.
This isn't really the traditional von Neumann kind of architecture, is it?
No, it's not. It's actually much more memory-centric, because we believe with all the data coming in the world today, then we're going to have to look at different architectures. And the important thing is it's built around the Gen Z technology. This is our technology for the interconnect that allows you the feeling of tying a whole machine together as one big machine. It is an open standard, so if you go to the GenZConsortium.org website, you can see all the other companies that are participating in it, from other OEMs to memory chip vendors to processor vendors and so forth.
Speaking of architecture, I understand you have an ARM kind of device here.
Yeah, absolutely.
Can you show us that?
I'll show you about that.
So Bill, what are we looking at here?
This is actually our brand new Apollo 70 system. This is an ARM-based system. It looks a lot like our Apollo 2000. The Apollo 2000 is Intel-based, but this one is based upon the Cavium ThunderX2 ARM processor. So it's a dual-socket motherboard. This particular server actually has 4 of those inside of it. And the great thing about this technology is that it has 33% better bandwidth than other existing microprocessors on the market today.
Why would it have more memory bandwidth than traditional things?
Well, because it's got more channels to memory. So it's got 8 channels to memory versus a lot of the other processors out there have six channels to memory from that perspective. And so, again, we've actually been shipping these to customers already as part of a POC project. So we already have an ecosystem of, like, OpenHPC works on here, RHEL, Red Hat, and also SUSE Linux as well works on this particular platform.
All right, Bill, what do we have here?
What we have here is our Apollo 6000 Gen 10. So this is, we had an Apollo 6000 Gen 9, and this is the latest version of that. Now, one of the feedback we got from customers on the Gen 9 version of it is that they wanted to have more integration. And so on the Gen 9, the power supply switches were actually outside the chassis, but in this case we've integrated it all within. So this makes it easier to deploy. It also gives us a lot more flexibility from that standpoint as well, so we can have a variety of different types of switch types, whether it's Ethernet, Omnipath, or InfiniBand as well. And the great thing about it is that we actually got a Reader's Choice Award for this from HPC Wire as the best server technology.
What would you call this form factor? What is
This is an enclosure type form factor.
Oh, gotcha.
So,
Okay.
so we could call it a tray or blade or however you want to call it from that standpoint. It actually has 24 blades, so it's actually has the perfect radix for Omnipath, which is a 48-port switch that's used as well, sort of thing. So we have a lot of customers that are enjoying this technology. BASF, for example, is the largest chemical company in the world, is actually using this today. And they have the largest HPC supercomputer in the world that's devoted to chemistry that's based upon this platform.
Well, Bill, a lot of innovation here on display at SC17. Keep up the good work.
All right,
it's
yeah,
great,
it's very
great stuff.
exciting. It's very exciting. And have a great show, Rich.